A manufacturer seeking an improvement in its marketing scheme is trying to determine if its market is aging. Past surveys show the average age of its users to be 27.8 years old. A random sample of 25 users of its product agreed to complete a survey. The ages of the users are listed in the table below. Can it be determined at the 0.05 level of significance that the average age of its users has increased? So we're testing about a mean. This is a one sample test. The hypothesized mean that we are going to test about is 27.8 years old. We have a sample size of 25. We do not know the population standard deviation, so therefore this will be a t-test, and we'll have to make some assumptions. We'll have to assume that the population is approximately normally distributed. So we'll draw our curve and take a look at what our hypothesized distribution is. We're hypothesizing that the mean is 27.8. Our intention is to use a sample to draw a conclusion about a population. And whenever we do that, sampling error is introduced. The question that's being asked is has the average age increased? Well, if the sample mean landed down here to the left, then we wouldn't support that notion at all, so we wouldn't even bother doing a hypothesis test. If our sample mean lands up here to the right, above 27.8, then we might start to believe that the average age of the population has increased, but we would only really be confident about drawing that conclusion if we land way up here in this unlikely area or in the rejection region, and we've decided that this time that area would be 0.05. Now, in order to determine our critical value, we'll need to know the number of degrees of freedom, which is n minus 1. So 25 minus 1 will be 24 degrees of freedom. So we're going to use a t-table to find this critical value. We can either look this up in a table, or we can use StatCrunch, or we can use the TI-84 calculator. If we use the calculator, we'll use the distribution function. So we push second, variables, and above that is distribution. We're going to use the inverse t distribution, so we'll push 4. Our area is 0.05. Our degrees of freedom is 24. The syntax is inverse t, open parenthesis, then alpha, comma, degrees of freedom, close parenthesis, minus 1.711 if we round to 3 decimal places. Now notice that's a negative number. Ours is a right tail test. It should be a positive number, and it will be a positive number because what we did this time was use 0.05 instead of 0.95. And we remember that this inverse t function uses the accumulated area. So if we were to push second, variables again, and do this again, and use 0.95 instead of 0.05, then we would get the right tail t value, which is the positive 1.711. So that's where you'll need to make a choice as to whether you use a left tail value or a right tail value for the accumulated area under the curve. So our critical t value is 1.711. Now we will need a t-test value. We can find the t-test value using the TI-84 calculator or StatCrunch. or any other means we have available to us. These values here, we will need to type into one of those utilities. To type them into the TI-84 calculator, we'll push Stat and then 1 for edit, and it'll give us an opportunity to edit some lists. Now I've already typed these in, and what we're going to want to do with them is find the t-test value associated with this sample. So we'll push Stat, Tests, we're going to go over to the Tests menu. T-test is number 2. Now it asks us, are we going to use some data that's in a list or some statistics that are already generated? Well, we are going to use the data that is in list 1. So we'll highlight data and hit enter, and now it gives us a chance to specify what the hypothesized mean is. Then it asks us, well, which list are those values in? And it was in list 1. Leave the frequency at 1. Choose the correct alternative hypothesis. So this time it's a right tail test. So we're going to want to use this one here. And then go down and hit calculate. And it gives us a test value of 2.325. Now something that we haven't done yet is specify our hypotheses, which we should do. Here now our hypothesis, our null hypothesis, is that this mean is 27.8. We are to test if it has increased. So is it now greater than 27.8? And this agrees with our curve and our critical value that's to the right, and our alternative hypothesis that we specified in the TI-84 calculator. We could also do this using StatCrunch. We would click Stat, T-stats, one sample with data, the data that we have in variable 1. So we'll choose variable 1 for this active box. We want to perform a hypothesis test with a hypothesized mean of 27.8. And this will be a right tail test. So we want to choose the correct inequality for the alternative hypothesis. Then we'll click compute. And we get a t-test value of 2.325, just like we did with the TI-84 calculator. Now here's something interesting. Our p-value is 0.0144. Notice that the TI-84 calculator gave us the same thing, 0.0144. And so let's write that down. Now we decided that if the p-value is less than alpha, we would reject the null hypothesis. Well, this is less than 0.05, which is alpha. So since the p-value is less than alpha, we should reject the null hypothesis. And we would make that same decision using our t-test and critical value. This value, 2.325, is up here in the rejection region, above 1.711, where if we land that far up there, we're just not willing to believe that the mean is 27.8 anymore. What we want to believe now is that it is greater than 27.8 because the data supported that. So our conclusion would be something like sufficient evidence was gathered at the 0.05 level of significance to conclude that the mean age of the users has increased.